In this part of the lecture, you'll learn how to complete the square on a quadratic function and to solve a quadratic equation by completing the square. The general idea is to rewrite our quadratic function, which is given in the form ax squared plus bx plus c, in the form p multiplied by x plus q all squared plus r. We'll begin with a couple of simple cases where we can complete the square by inspection, which literally means we can look at our quadratic expression and figure out how to complete the square. So let's consider example 1. We've got f of x is equal to x squared plus 2x plus 3. The part of the expression that interests us most are the two terms x squared plus 2x. And we should recognize this as being part of the expansion of x plus 1 squared. So we know that x plus 1 squared is equal to x squared plus 2x plus 1. If we compare x squared plus 2x plus 3 with x squared plus 2x plus 1, we can see that our example function f of x has a constant term which is just 2 greater than what we have when we expand x plus 1 squared. So we can rewrite f of x as being x plus 1 squared plus 2. So in completed square form, x squared plus 2x plus 3 is going to be x plus 1 all squared plus 2. Let's have a look at another example. Again, we're interested in the two terms x squared plus 6x. And we should recognize that as being x plus 3 squared, which is x squared plus 6x plus 9. We can see by comparison that our function f of x is x squared plus 6x minus 4. It's 13 less than the value of the constant term in x plus 3 all squared. So we can write our function f of x is equal to x plus 3 all squared minus 13. So that's the completed square form of x squared plus 6x minus 4. So that was quite easy, wasn't it? But what about when we have something like this? F of x is equal to 3x squared plus 6x minus 5. Well, what we're going to do is find a way of completing the square on this function, and then we'll use the result of that to solve the equation 3x squared plus 6x minus 5 is equal to 0. All right, let's make a start then. We've got f of x is equal to 3x squared plus 6x minus 5. And we'll start by writing that as 3x squared plus 2x minus 5 over 3. But we know from before that x plus 1 squared is going to give us that x squared plus 2x plus 1. So we can use that to help us again here. We can write this as 3x plus 1 all squared. We've got to take off the 1, haven't we, to balance this out. So we're gaining a 1 when we expand x plus 1 squared, so we want to take it off there. And we also want to take off the 5/3 we've got inside the bracket. So we can now multiply this out a bit. We'll get 3x plus 1 all squared. We've got minus 1 minus 5/3. So minus 1 is going to be minus 3/3. So it'll be minus 3/3 minus 5/3 is minus 8/3. But we're multiplying that by 3, so it'll be minus 8. So the completed square form of our function is f of x is equal to 3x plus 1 all squared minus 8. All right, let's use that result then to solve the quadratic equation 3x squared plus 6x minus 5 is equal to 0. What we're saying is that 3x plus 1 squared minus 8 is equal to 0. Because, of course, the two expressions are identical. 3x squared plus 6x minus 5 is identical to 3x plus 1 all squared minus 8. So we can recast the quadratic equation in this form. All we have to do then is take the negative 8 onto the right-hand side, divide by 3. We can then take the square root of both sides, so we'll get x plus 1 is equal to plus or minus the square root of 8 over 3. And then we take the positive 1 onto the right-hand side, so we'll get x is equal to minus 1 plus or minus the square root of 8 over 3. So that gives us our two solutions. So you've learned how to complete the square on some quadratic expressions and also how to solve a quadratic equation by completing the square. Now have a go at the multiple choice exercise following this subsection.